Alright, for today's lesson, I want to start by having us think about two concepts we've already learned about before. First, I want us to recall what the Pythagorean theorem is, and also what the equation of a line is. So if you guys can turn and talk to the person next to you and see if you can remember these terms. Alright, so can someone tell me what the Pythagorean theorem was? Yep, it's a squared plus b squared equals c squared, where c is our hypotenuse. And can someone tell me what the equation of a line is? Yep, it's going to be y equals mx plus b, where m is the slope and b is this point here. Alright, so these things have proven useful to us. And the equation of a line specifically, we use that to describe where a line is in a plane. And so my question to you today is, how might we describe where a circle is in a plane? If I know I have this circle here centered at 2, 2, and one of the points is at 5, 5, how can I communicate to someone else where my circle is exactly? And how can I find all the points that are on it? Well, I'm going to try building a triangle because I want to try to use my Pythagorean theorem knowledge. So what I'm going to do is draw a line from my radius to my point 5, 5. That's nicely labeled on my circle. And then I'm just going to connect it to make myself a right triangle. Okay, so what I realize here is that this is going to help me find the radius. So I know here if I label this side A and this side B, I'm going to be able to do a squared plus b squared equals r squared. And I can measure just by looking that this is 3 and this is 3. So I do 3 squared plus 3 squared equals r squared. 3 squared plus 3 squared is 18. And I take the square root of both sides to get that r equals the square root of 18. Alright, so this is great. I was able to find the radius of my circle, but I want an equation for it. Okay, how might I think about going about that? Well, one thing that I could notice is that A here, I can actually describe using the coordinates. So I labeled the center h comma k, just for now to have it labeled. And I'm just going to label this point x comma y, since it is the x coordinate and the y coordinate. Okay, so how can I think of A? Well, A is really almost all of this distance, right? Going out here. But instead, I didn't take this distance here, right? So I almost took it all, but I'm not taking this portion. Okay, well, how could I think of that? That's as if I went out to x, right? But I didn't take this portion, right? And so what would that mean? That would mean the whole length of x, but not this part. And what is the length of this part? Well, I know that it's h. So I can rewrite A as x minus h. Okay, now what about for B? Well, for B, I know that it's almost all of this length, but it's not this part, right? So that's the same as noticing that it's almost all of this length, but not this part. And so I know that's almost all of y, but not this part, right? From 0 to k, which has length k. So I can write it as y minus k. Okay, so now I know that A is equal to x minus h, and that B is equal to y minus k. And this still has to equal r squared because of a squared plus b squared equals r squared. And now I'm going to plug in my values. So I plug in 5 from here, and 2 from here, and I get 5 minus 2 squared, and then again the 5 and the 2, and so I get 3 squared plus 3 squared, which under the square root is going to be 18, and so I take the square root of both sides, I get square root of 18 equals r. Okay, so I got the same answers up here, so I know this is trustworthy. And why might I want to do this? Well, as you may notice, now this center is involved in our equation, right? And so is the radius. The radius is involved in the equation. And I have a variable x and y where I could plug in points, kind of like the equation of a line y equals mx plus b, where the y and the x, I could plug things in if I want to. Okay, so this is going to be useful since I can look at this equation, and if there were values here for h and k, I would know that the center is at h comma k. And I would know that the radius is whatever this is, so basically this under the square root, right? Because I know this is equal to r squared, and the radius would just be r. Okay, so now I'm going to ask you guys to try this example. I want you to try and see if you notice what will happen here when we take the equation of this circle. Okay, does anyone have any ideas? Yes, I agree. It's a little bit more confusing because of the 0, 0. It feels a little odd. But let me show you guys what I did. So, I first did it like normal with my Pythagorean theorem to check what the radius was, and I got the square root of 20. Did anyone else get that? Okay, perfect. And then I tried doing my center method. So with this method, right, I recognized my center was 0, 0, and even though that feels a little odd, I labeled it as h comma k. And then my x comma y, I did 4 comma 2. So I plugged those values in, and I got 4 squared plus 2 squared under the square root. So r is equal to the square root of 20. Did everyone else get that? Okay, yeah, that sounds good. A common mistake might have been to just be confused on what to do with this, or just to not put them there at all. So if you put something different than 0, 0, that would be wrong. But it is actually okay if you notice that you could just do 4 squared plus 2 squared. It's kind of like what you may have seen before as an equation of a circle, x squared plus y squared equals r squared. Just notice that we can't always use this because it's not going to tell us the center unless the center is 0, 0. All right. So we really trust this equation of a circle because we know a squared plus b squared equals r squared, but we can represent a as x minus h, and we can represent b as y minus k. And so we know that's still equal to r squared. This tells us the center and our radius. So for practice now, I'm going to ask, what is the equation of this circle? All right, I've given you some time. Would anyone like to share their answer? Oh, great. Yep, I think the 2 times square root of 2 is correct for the radius. Yes, so I did the same thing. I used x and y here, 3 and 2, and then I used my center here, 1 and 0, to go here. And then I went ahead and solved for the center and the radius. And something you may notice that's helpful is that in this first area is where our x coordinates always go, and this second area is where our y coordinates go. All right. Yes, you are right. We can write this as an equation. Finally, did someone get that? Great, yes, this is kind of just the scratch work, but we do like to put this back as x and y. So we have x minus 1 squared plus y minus 0 squared equals, and we can say the square root of 8 squared. And so this would tell someone that this is the radius, and that our center is 1 comma 0. Perfect. All right, and then just to end the class, a little idea of how this could be used in real life, because it is used in real life, is to imagine if the Earth was here, right? And let's say we're trying to send a spaceship out to over here, and it's gonna orbit the Earth and, look at the space and gather information. Okay, well, we're just worried about sending out here and then orbiting, right? And then bringing it back. Well, what if there was some danger here that we didn't know about? We think we're just sending it out this way and going around the Earth. But without the equation of a circle, we wouldn't know without graphing it that it's actually going to intersect that danger, right? And that we need to change our path to not intersect with that danger. So that's an example of how knowing where a circle actually is placed in space by using the equation of a circle can be useful.